Algebra 1, Unit 3 test review. For slope, it tells you there are 4 answers. You can have the formula, you can also have delta y over delta x. Remember, that just means the change in y over the change in x. You can have rise over run. And also remember, if you see the words constant rate of change, that means slope. And then if we do an example on a graph and a number of each of these, well, positive number, that could be anything. So you could say 3. Positive slope is going to go in the, like you're going up a hill. Negative slope is like you're going down a hill. That could be a negative 3. And then a vertical slope, or vertical line. And remember, we can use VUX. So that means a vertical line has undefined slope. And so in this case, that would look like if you end up with a 0 in the denominator. So if you have 3 over 0, that 0 in the denominator would mean that you have an undefined slope. Then if you have a horizontal line, there's a horizontal line. We can use the saying HOI. That means the horizontal line has a 0 slope. And as a number, you would end up with either just a 0, or if you have 0 over any number, then that is a 0. If we're going to find the slope of all of these points, we need to use the slope formula. If you need to, you can always label x1, y1, x2, y2. So we could write the slope is negative 3 minus 2 over 1 minus 1. So that's going to be negative 5 over 0. Remember, 0 is in the denominator. That is an undefined slope. And then if we do the next one, negative 4 minus negative 4. Be careful anytime you have a double negative. Then we have 6 minus 3 for the x's. That double negative is a positive, so we have 0 over 3. Well, 0 is on top, then the slope is 0. And you can just write a 0. I'm just writing it out. And then for number 5, we've got negative 4 minus 5 over negative 8 minus 4. So that is negative 9 over negative 12. Remember that it is best to leave slopes as fractions. So if I reduce that, it's going to be a positive 3/4. And then number 6 is just trying to be tricky. You just have to pick 2 of those points to use to find the slope. So I'm going to pick the 2 with the smaller numbers. So I have 2 minus 0 over 0 minus 5, and that slope is going to be 2 over negative 5. For number 7, if we have a non-linear equation, a couple of things, or several ways that you can tell that it is non-linear. So once you have solved for y equals mx plus b, if on the right-hand side, so the opposite side of the y, if you have an x in the denominator, then it is non-linear. Also, we'll want to do an example. That could be y equals 3 over x plus 6. That would be non-linear. You can also have, if you had a y equals, you had an exponent other than 1 on your x, that would be non-linear. And then also, once you've solved for y, there should not be a y on the other side that is multiplied by something that you can't get rid of it. So for instance, if you had xy plus 6, that would be nonlinear. Okay, determine if the equation is linear. If it is, write it in standard form. Most of the time, it's actually easier to tell if it's in standard form in y equals mx plus b form. So right now, if we look at number 8, This is probably the one time that I would tell you don't put it in slope-intercept form to check, because it's very easy to write this one in standard form, because all you have to do is switch the x and the y. So you'd say negative x plus y equals 3. Now the two rules for standard form is you can't have a negative in the front, and remember that's kind of controversial, so technically you could see this answer negative x plus y equals 3, but we're going to go ahead and get rid of the negative just to be consistent. So you can either multiply or divide every single term by negative 1, so that would be x minus y equals negative 3. So now you see both examples of how it could look, whether you let a stay negative or if you make it a positive. If you check number 9, it is already solved for y, but there is a y that we cannot get rid of on the right-hand side. So therefore this is nonlinear. I should put linear over here. And then if we look at number 10, that's actually technically in slope-intercept form. I could write it y equals 2 over 5x minus 3 over 5. Here's another example where it would actually be easier if to go to standard form. So you recognize that it's in slope-intercept, so you know that it is linear. Then to go to standard form, get rid of your fraction first. So multiply both sides by 5. You have 5y equals 2x minus 3, because those 5's cancel. Then you need to move your x term to the left, so minus 2x. So you have negative 2x plus 5y equals negative 3. Now, I'm not going to show my work this time multiplying or dividing everything by a negative. I'm just going to change each of my signs because that's all that that's going to do for us. So 2x minus 5y equals positive 3. Okay, let's look at number 11. Once again, I would always suggest get rid of your fraction first, even if it is a binomial. So I'm going to multiply by 2x minus 5. So remember, on this side, those just cancel out that denominator. And I'm going to multiply 2x minus 5 on that side. But remember, if you're multiplying a monomial times a binomial, you have to distribute. So that's going to end up being negative 4x plus 10 equals y. So right there, I can tell that this is linear, because that's technically slope-intercept form. If I rewrote it, y equals negative 4x plus 10. And then this time, I've got to get my y on the left side and my 10 on the right side. So let's go ahead and, I'm going to go ahead and minus 10 first. So negative 4x equals y minus 10. Then I need to minus y. Now, if you want to, you could have done that at the same time. So there's standard form, but a is negative. So I'm going to change all the signs, and so I'm basically multiplying or dividing by negative 1. So if I do that, that's 4x plus y equals 10. Also, we didn't have any in these practice problems where we had to clear the fraction, because you cannot have a fraction in standard form, but we have practiced clearing fractions a lot recently. So for number 12, given those two ordered pairs and the slope of negative 5/3, calculate the missing value. In this case, we're going to have to use our formula, m equals y2 minus y1 over x2 minus x1. Now the thing that's a little bit different about this is that they actually give us the slope. So I've got to plug in negative 5/3 for this m. So we have negative 5/3 equals, now I'm going to jump to my 2 points, 2 minus 7 over 1 minus x. Now if we treat this like a proportion, and before I do that, I'm going to go ahead and simplify this right here, the 2 minus 7. So I've got negative 5 over 3 equals negative 5 over 1 minus x. Now I actually see a little trick that I could use here, but I'm not, just so that I can practice using this proportion. I'm going to put parentheses around my binomial so that whenever I cross multiply, we've got negative 5 times 1 minus x equals 3 times negative 5, which is negative 15. And now we're just going to distribute and solve. So negative 5 plus 5x equals negative 15. So if we plus 5, so 5x equals negative 10, and divide by 5. X equals negative 2. Number 13, Henry was saving money for a new car. The equation S equals 100M for the amount of money in savings after n months. Write a sentence to interpret the slope of the equation. So you could just say that he is saving $100 per month in his savings. Number 14, a car is expected to decrease in value according to the equation y equals negative 1500x plus 25,000, where y is the value of the car after x years. The meaning of slope, the slope is negative 1500. And since it's negative, we know that it's going to decrease. It also tells us that in the problem, but it won't always. And so we know that it is going to be decreasing $1,500 every year. So it's going to decrease in value $1,500 every year. The y-intercept, you can always look at that as the starting point. Now in this case, since we are buying, or he's buying a car, that is the starting price of the car. 15, give 2 points that are solution to the equation y equals negative 2x plus 3, and 1 point that is not. There's several ways that we could do this. The easiest way would be to actually use your calculator. So you could plug this equation into y equals. Plug it into y equals, since it's in y equals mx plus b form. And then you're going to look at your table. And the way you get to your table is you're going to press second, graph. And that is going to take you to the table. And then you'll have plenty of values to choose from, to pick that are on there. So in this case, I'm going to do that real quick. Okay, since I don't have a calculator with me, I am going to just pick a number for x. So I'm going to say let x equals 1. X equals 1. So if I plug it into that equation, so y equals negative 2 times 1 plus 3, and if I solve for y, that would be negative 2 plus 3, so y equals 1. So that would be one pair that works, one ordered pair. Then I'm going to do it again, and I'm going to let x equal, I'll just do 0. And then I'm going to solve for y. So I have y equals negative 2 times 0 plus 3. So y equals 3. So that would be another pair that is a solution to that equation. And then if you want one that is not, since we had 1, 1, you could pick one that is not by just changing one of those two numbers. So in this case, if you let x equal 1 and you said y equals 2, or you wrote it as an ordered pair, because remember you can do that too, those are not, that is not a solution. So that would not lie on the line. So the purple and the red are solutions. For number 16, if we need to do the slope and y-intercept, the easiest way to identify is to put this in slope-intercept form. So minus 4x. You got to get the y by itself, so negative 7y equals negative 4x minus 28. and divide by -7 under every term. This is not the time to not do it individually. Y equals 4/7 x plus 4. So the slope is going to be in front of the x, 4/7, and the slope-intercept is going to be the +4. For number 17, the solution of x, if x2 is a solution to f of x equals 3x plus 1. So they are actually giving us the y value as 2. So we can take that and plug it in for f of x. So 2 equals 3x plus 1. So if we minus 1, we end up with 1 equals 3x. And if we divide by 3, x equals 1/3. So the value of x here would be 1/3. If you plugged in a 1/3 for x, you would get out a 2 for y. Okay, number 18, draw a vertical line. So that's up and down. There's a vertical line. And if we write this equation, when we think of vertical lines, you can use that saying VUX, and that means it's going to start with an x. So x equals, and it's going through the 2 in the x-axis. So the equation for that line would be x equals 2, and the slope is undefined. If we do the same thing for a horizontal line, we would use HOI. And if we do a horizontal line, I'm going to put down here, that is 4 on the y-axis is where it's cutting through. So the equation is going to be y equals -4, and the slope is going to be 0. The parent linear function is just y equals x. And remember, you can also write f of x equals x. Remember, with the parent linear function, the slope is 1, and the y-intercept is 0. For 21 and 22, we need to graph the functions with the x and y-intercepts as ordered pairs. Now, in this case, you do have a couple of options in how you graph these, but you can also, since they are both in standard form, it's pretty easy to go ahead and graph using the x and y-intercepts. So in this one, I like to use a method where I rewrite the equation, because I'm going to zero out the x in one of them and the y in the other. And now I'm just going to solve. So in the top one, I can see that y equals 3, so the y-intercept is 1, 2, 3. And now in the second one, I do need to solve for x because it's a negative x. So I end up with x equals -3. And then I could draw a line between those two. You could always use your ruler, or you could count with the slope once you have your 2 points down. And if we do the same thing with number 22, I'm going to write it again. Now I found if I do this, I make less mistakes because just in one of them, I let the x equal 0. I zero out that term, and then I let the y equal 0 in the other one, so I zero that out. And then I solve for whatever variable is left. So y is -3. And then if we solve here, x equals 4. And we connect that x and y-intercept. Okay, if we need the slope and the y-intercept of number 23, we just need to put it in slope-intercept form would be the easiest method. If we subtract 2x, -5y equals -2x plus 20. Divide by -5 under every term, and we end up with y equals y equals 2/5 x minus 4. So the slope is 2/5, and the y-intercept is -4. On number 24, we need to use the table of values, find the x and y-intercepts of the linear function, and express our answers as ordered pairs. And I've already graphed or plotted those points on the graph, And then just to get the most precise line I possibly can, I'm going to go ahead and count from point to point and get my slope. So I went down 2, left 1, down 2, left 1. Well, that's my y-intercept. Down 2, left 1, down 2, left 1. So that's a pretty good line. So I know my y-intercept is 0, 3, but the x-intercept, and I did a bad job drawing that, is right here. Now there's a couple of things. At this point, I would just allow you to go ahead and estimate that as -1/2, 0. Now, if you want to check your answers, since you've done slope-intercept form before, you could write an equation for this line because you know that the y-intercept is 3, so that is b. You know your slope is up 2, right 1, so your slope is 2. So then we could write y equals 2x plus 3. Now, in doing this, we can check our x-intercept by plugging in 0 for y. So if I say 0 equals 2x plus 3, and if we solve for x, -3 equals 2x, and if we divide by 2, so x equals -3/2, which is also -1.5. And I should have put this over here, -1 1/2. Sorry about that. -1 1/2. So I did estimate correctly once I put that 1 in there. Okay, so for 25, we need to write an equation for the line below. This is the line that we are looking for. Since it is a vertical line, it's going to start with x equals, and it goes through x equals 4. That is going to be the equation for the line. If it had asked for the slope is undefined. So we use bucks for that. We're going to graph number 26. Remember, you have the option to use the x and y intercepts, and this would be a good one to do that with. But I'm going to go ahead and solve for y equals mx plus b, since you have graphed in that method before. So I'm going to go ahead and plus 5 to the other side. And I'm also, I'll do this anyway. So 3x minus y equals 5. Now that's standard form, so I could really use x and y intercept from this form if I wanted to. But I'm just going to go ahead with my original thought and put it in y equals mx plus b. And then, since I have a negative y, I've got to divide every term or multiply every term by -1. So we have y equals 3x minus 5. Remember, in this form, you always start with your b, so you go to -5. And then your slope is 3, so you go up 3, right 1. Up 3, right 1. And then down 3, left 1. For number 27, what is an x-intercept and what are the other terms for it? So an x-intercept is where a line or a graph touches the x-axis, and we can also call that a solution, a root, a 0, and an x-intercept. For 28, we want to know what the x and y-intercept of that line, and write our answers as ordered pairs. So it touches the x-axis at -5, so that's going to be -5, 0. And then it touches the y-axis at 5, so that's going to be 0, 5. So those would be our ordered pairs. For 29, we need to determine the 0 of the equation by graphing. So if you wanted the 0, remember, that's just the x-intercept. So we just need to graph. So since it's in standard form, I'm going to go ahead and graph using the x and y intercepts. I like to use that method where I write it twice, because then I'm going to zero out one variable in each equation and then solve for the variable that is left. So I'm going to zero out the x in this top equation, the y in the second equation. Divide by 2. So y equals -5. And then divide by 5. X equals 2. So there's my graph. And then this point right here, the x-intercept, so that is going to be 2, 0. Notice you don't technically have to graph, but since it asked me to, I needed to graph also. Okay, if we look at number 30 and 31 and 32, we have to sketch an example of each of the following. So the first one, we need an example of a linear non-proportional. So non-proportional means it's not going to go through 0, 0. So you can draw any line that is not going through 0, 0. That could be a positive slope or a negative slope. So either one of those are a good example. If we want a proportional function, that just has to go through 0, 0. So there would be a good example. Could also have a negative slope also. And then non-linear, just anything that is not a line. So you could do something like that, or you could draw this U-shaped graph. We'll talk about those in the future. Both of those are non-linear. Okay, if we look at number 33, we're going to identify these functions as linear, non-proportional, proportional, or non-linear. So remember, the linear non-proportional mean that you end up with y equals mx plus b, and b is not 0. If you end up with proportional, that's going to be y equals mx, because b is going to equal 0. So it's going to go through the origin. And then non-linear, you're looking for several things. Once it's in y equals mx plus b, if whenever you get it to that form, then you're either going to have an x in the denominator, or you're going to have an exponent other than 1 on your x. So the easiest thing to do first is to start getting these in slope-intercept form. So on the first one, I can already tell that this is going to be linear, non-proportional, because I can get it in y equals mx plus b form, but it has a b, it's not 0. Okay, if we look at the second one, if I solve for y, if I subtract minus 3x squared, so y equals negative 3x squared, minus 1, I can tell that this is non-linear because it has an x squared. And that would have to be a 1 as an exponent to be linear. Then we have y equals 3.2. Well, this is one of our special cases. This is a hoist, so it is a horizontal line. Going through 3.2 on the y-axis, so it is linear, non-proportional. And then lastly, if we solve for y here, I'm actually going to do something a little bit different. I'm going to go ahead and plus y, because that saves me a step. So I have 12x equals y, and it's perfectly okay to go ahead and switch those around. So say y equals 12x, and this is going to be proportional because there is no b. So that's an understood plus 0 that you do not have to write, so that's why it is proportional. That's also called a direct variation. Number 34, is a proportional function linear or nonlinear, why or why not? Well, it is a linear function because it is a straight line that goes through 0, 0, and you can write it y equals kx, and remember, that's just a variation constant, which also acts as our slope in this case. On 35 through 37, we need to write an equation of the line shown in function form. So for 35, and to do that, and don't let function form bother you, that just means y equals mx plus b. but with instead of writing a y, writing f of x. So we just need to identify the slope and the y-intercept of each of these. So there's the y-intercept. I need to pick another point so I can count the slope. 1, 2, 3 over 1. So the slope is 3 over 1. Y-intercept is 2. So I can say that f of x equals 3x plus 2. The second one, y-intercept is 2. The slope is up 1, right 2. So we can say that f of x equals 1/2 x plus 2. And then for this last one, the y-intercept is 4. And I'll pick another point. So my slope, you always do rise first. So 1, 2, 3. And then this time we go left 2. So that's negative 2. So we can say that f of x equals negative 3/2 x plus 4. For number 38, Hooke's law for an elastic spring states that the distance d a spring stretches varies directly as the force F is applied. Write a direct variation equation using d, f, and k. Now, the one thing you need to look for in these problems is whenever it says varies directly, because a lot of times we use x and y with these equations, but here we don't have an x and y. So whatever variable comes before the varies directly is going to be your y, and whatever comes after is going to be your x. So normally we would write y equals kx. That's the equation that you need to have memorized for direct variation. And we're going to replace that with a d for the y equals k times f. So that would be our equation with using the variables from the problem. And then if we look at B, if a force of 160 newtons stretches a spring 5 centimeters, how much will a force of 368 newtons stretch the same spring? So first thing we need to do is find out what our K is by plugging in, this is force, this is distance. So whenever we plug those in, we have 5 equals K times 160. And we need to divide by 160 to find our K. So K equals 1 over 32. So now we need to take this K value that we just found and use it in the same equation if the force is 368. So we're still going to use our same equation, D equals KF. So this time we're solving for our distance. So we know our K is 1 over 32. Our force is 368. And that is going to solve for D. So really we just need to do 368 divided by 32. And we end up with D equals 11.5 centimeters. Okay, for the next one, we need to find the 0. Remember, that's the x-intercept of that function. So when you need the x-intercept, you just plug in 0 for y. So we're going to 0 out that y. F of x is just a fancy way to write that. So we have 0 equals 3x minus 6. We plus 6 on both sides, so we have 6 equals 3x. Divided by 3, x equals 2. So the x-intercept, if I write it as an ordered pair, is 2, 0. We need to find the slope for number 40. You just need to pick 2 points. You don't need all of them. So I'm going to pick, really, they're both pretty even as far as how many decimals they have. So I'm just going to pick these top 2. And I don't like to write it from the table. I'm going to go ahead and write those points out. So negative 3, 5, negative 2, 2. And I'm going to plug them into the formula. y2 minus y1, so that's 2 minus 5 over negative 2 minus negative 3, so that's negative 3 over, that turns to a plus 3, so over 1, so the slope is just negative 3. For numbers 41 through 44, we need to check to see if these sequences are arithmetic. If they are, we need to write the next three terms and the nth term. So arithmetic, you need to find a common difference, so if you can subtract. So for number 41, it looks like to go from 35 to 32, we are subtracting 3, but here we're subtracting 2, subtracting 1. So this is not an arithmetic sequence. If we look at number 42, we have, let's see, we minus 20, then minus 20, and then minus 20. So our common difference is minus 20. So if we do the next three terms, we would just have to minus 20. So that would be negative 83, negative 103, and then negative 123. And then if we need to write the nth term, we need our formula for that. And that is a sub n equals a sub 1 plus n minus 1 times that common difference. So in this case, our a sub 1, that's the first number. And then, so we have our a sub n equals negative 3 plus, then we have n minus 1. I'm running out of room, so I'm just going to write over that negative 123. And then we have our common difference, so negative 20. So that would be our equation, the nth term, how to find the nth term. Okay, before I stop on this one, let me go ahead and distribute. So remember, this is the one thing that's a little bit weird about this, using this formula. You're going to have to distribute that common difference. So we have a sub n equals negative 3. Then we have negative 20 times n, so minus 20n, and then plus 20. So then if we simplify, that is going to be negative 20n plus 17. Okay, if we go to 43, let's see if there is a common difference. So between these two, that would be a minus 30. Here is a minus 30. Here is a minus 30. So now we have to do the exact same thing. So our common difference is minus 30. And then if we go ahead and do negative 124, and if we minus 30, that's going to end up being negative 154. Minus 30 is negative 184. And then minus 30, negative 214. Now we use our same formula up here. So it is a sub n equals a sub 1, that's just the first term, plus parentheses n minus 1 times that common difference. So our a sub 1 is negative 34 in this case, plus n minus 1 times our common difference, which is 30. We have to do the exact same thing where we distribute. So negative 34 minus 30n plus 30. So we would end up with a sub n equals negative 30n minus 4. Okay, if we check the last one, so it looks like we are subtracting 10 there, and here, and here. So that would make our next three terms negative 70, negative 80, negative 90. We write our nth term, so we have a sub n equal our first term that's given, so that's negative 30 plus n minus 1 times our common difference, which is 10. Remember, you're going to have to distribute that. So we have a sub n equals negative 30 minus 10n plus 10, and if we combine like terms, a sub n equals negative 10 n minus 20. Okay, number 45. Cell phone companies often package their products to make them more attractive. If you average 365 minutes per month in talk time, which package is a better deal? So we want to say we use 356 minutes a month. So package A includes a free phone and 300 minutes. It costs 12 cents per minute for each minute over the planned time. Package A has a base rate of $39.95. So it looks like we're going to have to set both plans, maybe not necessarily equal to each other, but we're going to have to write both plans out. So it has a base rate of $39.95 plus, in this case, you get a free phone and 300 minutes. So then you're going to have 56 minutes at 12 cents per minute. So that's package A. So it looks like we might not even have to set them equal to each other. We might just be able to plug in. It says package B has a phone that costs $10 and then 350 minutes of time and 8 cents per each minute over that planned time. Package B has a base rate of $35.95, not including the phone. So then we have to add in that each additional minute over the 350 that is included, so that would only be 6 minutes, is 8 cents. So now you just have to see which one is more expensive. And after doing those calculations, just barely, Plan B is a better deal. Okay, so if we look at number 46, it says the gas tank in a car holds 16 gallons. It travels 75 miles on 4 gallons of gas. If the tank is full at the beginning of the trip, which graph represents the rate of change in the amount of gas in the tank? So first and foremost, if you start out with 16 gallons, that should be our y-intercept. So we can go ahead, any of the graphs that do not start at 16, we can say that those are not going to be our answers. And if it's going 75 miles on 4 gallons, you can use that in your graph, but I'm going to go ahead and see if I can reduce that at all. So 75 divided by 4, 18.75 per gallon. So 18.75 miles every 1 gallon. And we normally don't like to do our slope as a decimal, but in this case, it might be easier to look at our graph. So I'm looking for one that's about, 18 miles in 1 gallon. And actually, let's look over here because our graph is going down by 2 in the gallons in the tank. So I'm actually going to redo this, 75 divided by 4, and I'm going to divide each of those by 2. So that's going to be 37.5 gallons every 2 miles. And this is only because this is going to be the easiest way for us to look at this graph. So if I use 2 gallons of gas, then whenever I come over here, I should have gone 37.5 miles. Well, if I look down for graph 1, I haven't even gone 30 miles. So let's look down here. So here, if we go down 2 gallons of gas, and then we come over here and look, we've gone just over 30 miles. So it's going to have to be graph 2 matches with this problem.